Department of Physics and Astronomy at the University of Toledo has been pushing the limits of solar cell science and technology for nearly 30 years. Today, with unrivaled facilities, outstanding personnel and faculty, and a can-do spirit, Toledo is the place to be if you see your future in photovoltaics.
My research stems with thin films for photovoltaics. So we look at fabrication of them, characterization of them, figuring out why they work, figuring out why some of them don't work as well as we expected. So it's really neat to be able to look at, the underlying fundamental physics behind how, thin films are deposited, the properties we end up with, and then how those properties impact the device physics itself. You can take students who are interested in more computational aspects, more hands-on aspects, and you can kind of bring everything together with how these devices work and how you make them.
This was our original CAD-TEL room. Let's say we're making a CAD-TEL device. We start with a piece of glass from whatever partners we have.
Okay.
It's a piece of glass. It's transparent, but it's not conductive. So we start by depositing a transparent conducting oxide. Then we put down in CAD Telluride, it would be an electron transport layer or an emitter in the CAD Telluride field. On top of that, we put the absorber. That would be in this system, so this is an evaporator. We would evaporate CAD selenide and then CAD Telluride on top of it. We would go to the wet chemistry lab, do a CAD chloride process treatment. So we apply CAD chloride to it through wet solution process. We run a thermal profile, clean off the excess CAD chloride. Then we got to put a back contact in. We have all kind of options there.
Perovskite is actually a crystal structure, the class of the material. And here we are mainly work on one specific perovskite material, one family that's called organic inorganic metal halide perovskite. So this material consists of the organic species, have a metal cations, and have halides. What makes this material so amazing is this material has some special, unique optoelectronic properties. So they have high absorption coefficient. So that means you can make that ultra thin absorber layer to harvest all the sunlight energy. And also this material can be processed using solution-based method or low temperature vapor-based method. So you can significantly reduce the manufacturing costs and the energy input to fabricate the material. And it's also special for the defect tolerance property. So instead of making single crystal material, we can make polycrystalline thin film. And also that shows pretty good efficiency and minimize energy loss.